Hi, this is my monthly rant on genetics and human beings, and we're not descended from apes, and we don't have to be. Ancient humans are mostly based out of Africa, and modern humans are descended from them primarily. Neanderthals primarily from Europe, and Denisovans primarily found or ended up in Asia, but we only know that from one example, and it's 3 bones. But just like a CSI episode, we got lucky in some cases, and in this case, we got genetic information from all 3. You'd be surprised how many modern humans there are you can get DNA from. So anyway, and that's actually, the Denisovans are now overrepresented in Melanesians. That's an area around, you're going to have to look it up because it's this weird, I hate how scientists, it's basically an Oceania, or something like that. Anyway, all of these humans or human-like creatures that ended up contributing to our DNA have 23 pairs of chromosomes. We are freaks. Bonobos, chimpanzees, gorillas, orangutans, etc. have 24 pairs of chromosomes. Neanderthals diverged from humans, or from what are we, and they diverged from the same origin, which we're not really even sure of, about almost 600,000 years ago. The Denisovans genome, we don't even know exactly when it diverged, is 17% Neanderthal. That's the only thing we know about it. And non-African modern human DNA, mostly from Europe, is 1 to 4% Neanderthal. Mostly of it is affecting our X chromosome, but not the Y chromosome, which caused one-way interbreeding, meaning women, let's say a man and woman get together, the baby would only be able to be viable if it was female. So you only have the female lineage containing Neanderthal and human, or vice versa. It depends on what you're doing, and who's doing what to who, and I'm not going there. So let's go on to the next. Human chromosome, this is where we get this from. And it's really clear if you look at the DNA sequence. Like, literally impossible not to notice this. The human chromosome has human chromosome number 2 has a near identical DNA sequence and pattern from the ape chromosome for chimpanzees, gorillas, and orangutans, and a whole bunch of others in DNA. But instead of it being in chromosome number 2, it's in 2 separate chromosomes. And if you sequence them, the only way they work is they connect like this, which can happen with a virus, and it's most likely a viral mutation. This also happens in plants a lot, and also in animals. Also, there are people walking there that also have this happen spontaneously. The DNA chain sequences together. It doesn't affect anything because the little thingamajig that figures it all out figures out how to fuse them together when you have kids. It can cause genetic abnormalities and or mutations, but it isn't a death sentence for the offspring or for the person. In the middle of the human chromosome number 2, at the q13 band, are additional telomere sequences, and at q21.3 and q22.1 region in that area, through that area, you get remnants of centromeres that aren't supposed to be there. This vestigial telomere and centromere behavior indicates a mutation where they fuse together. Telomeres are normally on the ends of chromosomes, and centromeres, are normally in the middle, but they're not supposed to be in that particular position, and those DNA chains show this as markers. We are the result of a mutation. That's the idea behind it. If anybody was curious, that's what this video is about. Thanks for watching. Have a good day.